Welcome back to another episode of Second Career Pilot.
Great to be here.
Today, we're really getting into the fundamentals, specifically airplane attitude instrument flying.
Yeah, a core skill.
Definitely. For anyone moving into aviation or, even experienced pilots needing a refresher, understanding how to fly purely by instruments is just critical, especially when you lose those visual references.
Absolutely. It's all about maintaining control when you just can't see outside.
So let's unpack that. What's the big shift from flying visually to flying on instruments?
Well, normally you're relying heavily on the natural horizon, right? Your peripheral vision, everything is oriented to that outside view.
Makes sense.
In instrument flight, that reliance shifts entirely inward to the flight instruments right in front of you.
They become your new horizon, essentially.
Exactly that. Your attitude indicator, your altimeter, airspeed. They provide the same essential information about the aircraft's state, just, presented differently.
And understanding that is key, I imagine, especially if an instrument were to fail.
Precisely. Knowing how the instruments relate to each other and to the aircraft's performance helps you cross-check and catch potential problems.
Okay, so how do we learn this? I know there are a couple of main methods taught.
That's right. You generally hear about the control and performance method and the primary and supporting method.
And they both use the same instruments, right?
Correct. Same instruments, same control inputs needed. The main difference lies in sort of the philosophy, particularly how much initial emphasis is placed on the attitude indicator versus other instruments for specific maneuvers.
Got it. For today, maybe we can focus on the principles that apply across both.
Sounds like a good plan, because the underlying concepts of how you interpret and use the instruments are universal.
So let's start with the instrument categories. You mentioned control instruments.
Yes. Control instruments give you immediate, direct indications of attitude and power. Think of the attitude indicator itself showing pitch and bank instantly.
And for power.
That would be your manifold pressure gauge, tachometers, maybe fuel flow meters, depending on the aircraft. They show your power setting right now.
So you use these to make the actual adjustments.
Exactly. Precise changes to attitude and power start here.
Okay, then what about performance instruments?
Performance instruments tell you the result of those control inputs. They show the aircraft's actual performance.
Like the altimeter.
Yes, the altimeter showing your altitude, the airspeed indicator showing your speed, and the VSI, the vertical speed indicator showing your rate of climb or descent.
So control is the input, performance is the output.
You've got it. They tell you if your inputs are achieving the desired outcome.
And there's a third category, navigation.
Right. Navigation instruments. These show your position relative to navigation aids or points. Things like VOR course indicators, GPS displays, glide slope indicators for approaches, bearing pointers.
Although on newer planes, this is often all blended together, isn't it?
Increasingly so, yes. Glass cockpits integrate a lot of this information onto primary flight displays, which really helps with situational awareness.
Okay, let's walk through the steps, maybe using that control and performance idea. Step 1.
Step 1 is establish. You set a known or calculated attitude and power setting on those control instruments that you anticipate will give you the performance you want.
So you're making an educated guess based on the flight phase.
Pretty much. You use known power settings and approximate attitudes for climb, cruise, descent, etc.
Then step 2, trim.
Yes, trim. This is so important. After establishing the attitude, you trim to neutralize the control pressures.
Why is that so crucial?
A well-trimmed aircraft is stable. It reduces your workload significantly, letting you dedicate attention to scanning, interpreting, and other tasks, rather than constantly fighting the controls.
Makes sense. Less effort, more brain power available. Okay, step 3.
Step 3, cross-check. Now you systematically scan those performance instruments. Are you actually getting the altitude, airspeed, and vertical speed you intended?
This involves not just seeing, but interpreting what you see.
Exactly. You need to see and understand. How far off are you? Which way do you need to adjust?
Which leads logically to step 4.
Step 4, adjust. Based on that cross-check, you make small, smooth adjustments to the attitude and/or power using the control instruments again.
And then you trim again, presumably.
You trim again, yes. It's a continuous cycle. Establish, trim, cross-check, adjust. Establish, trim, cross-check, adjust.
Let's focus a bit more on controlling the attitude itself. The attitude indicator seems central here.
It really is. It's your only instrument giving you a direct, immediate picture of both pitch and bank.
So for pitch nose up or down, what are we looking at?
You're looking at the relationship between the miniature aircraft symbol, or sometimes just a fuselage dot, and the artificial horizon line.
How precise do those adjustments need to be?
Very. Small changes on the indicator mean real changes in altitude over time. Corrections are often measured in fractions of a degree or maybe a bar width on the display. The amount you adjust depends on how far off you are from your target performance.
And for bank, rolling left or right?
You use the bank pointer or index against the bank scale, usually marked in degrees 0, 10, 20, 30 degrees are common reference points.
Is there a rule of thumb for turning?
A common one, especially for standard rate turns in slower aircraft, is that your bank angle in degrees roughly approximates the number of degrees you need to turn, but you generally don't exceed about 30 degrees of bank for standard instrument flying.
Okay, let's talk power control.
Power control is about smoothly getting to and holding your desired airspeeds, and it works hand in hand with attitude control.
Primarily throttle adjustments.
Yes. Using the throttle and referencing those power indicators, manifold pressure, RPM, N1, whatever applies to your aircraft.
An important point about power indicators.
They aren't generally affected by turbulence or trim state like, say, the attitude indicator might momentarily be. They give a pretty solid indication of what the engines are doing.
But you shouldn't fixate on them.
Definitely not. Avoid staring. Know your approximate power settings for different phases of flight climb, cruise, approach, and use the indicators to confirm and fine-tune.
Now, briefly, how does the primary and supporting method conceptualize this?
It looks at the same instruments, but thinks about them in terms of which one gives the most pertinent information for a specific control function pitch, bank, power, or trim during a specific maneuver.
So the primary instrument can change depending on what you're doing.
Exactly. It shifts the focus based on the task.
Okay, let's take pitch control in straight and level flight using this method. What's primary?
In level flight, your altimeter is primary for pitch. It directly shows if you're maintaining altitude.
And the supporting instruments.
The attitude indicator is supporting, giving that direct visual of pitch attitude. The VSI supports by showing the rate of change, are you stable, climbing, or descending? And the airspeed indicator provides an indirect pitch indication.
How so?
Well, if your power is constant and your airspeed starts decreasing, it implies your pitch attitude has increased and vice versa.
Ah, I see. What about common errors in pitch control?
Over-controlling is a big one, making adjustments that are too large. Also, using power improperly, maybe trying to climb just by pulling back without adding power, or not cross-checking enough to catch deviations early.
Okay, shifting to bank control using primary and supporting.
Yeah.
What's primary for maintaining a heading?
The heading indicator is primary for bank control in a turn, or when maintaining a heading. It shows you directly if you're turning off your desired heading.
And supporting instruments for bank.
The attitude indicator is supporting, showing the direct bank angle. The magnetic compass also supports, but it has errors, lags. It's more for overall orientation. And then your turn coordinator or turn and slip indicator.
What's the difference between those two?
The older turn and slip indicator just shows the rate of turn. The turn coordinator, the one with the little airplane symbol, initially shows the rate of roll as you enter the turn and then stabilizes to show the rate of turn. Both also have the inclinometer, the ball, for coordination.
Got it. And for power control in level flight, primary is?
Airspeed indicator. In level flight, airspeed is the most direct indication of whether your power setting is correct for maintaining level flight at that speed.
Supporting instruments for power.
Your engine instruments, manifold pressure, RPM, etc. They show the power being produced that results in that airspeed.
We mentioned trim earlier, but let's reiterate its importance.
Cannot stress it enough. Proper trim is fundamental for smooth, accurate instrument flying. It frees you up mentally.
And the process is?
Establish the desired attitude using control pressure, then adjust the trim so the aircraft maintains that attitude when you relax the pressure. You also trim for coordinated flight using the ball in the turn coordinator.
But you don't use trim to make the initial change.
No. Trim follows control input. It doesn't replace it for establishing a new attitude.
So, bringing it all together, what are the absolute bedrock skills we need?
It boils down to two fundamental skills: instrument cross-check, often called scanning, and instrument interpretation.
Let's take cross-checking first.
It's the continuous, logical, systematic observation of the instruments to understand the aircraft attitude and performance. You're constantly moving your eyes between relevant instruments.
And which instruments are relevant changes?
Yes, it depends entirely on the maneuver. In straight and level, you might focus more on altimeter, heading, and attitude. In a climb, airspeed, attitude, and VSI become more prominent.
Are there specific patterns recommended, like the T-scan or others?
There are several described patterns, selected radial, inverted V, rectangular, but the FAA doesn't strictly mandate one. The key is developing a pattern that works for you, covers the critical instruments for the current maneuver, and avoids fixation.
What are those common scanning errors?
Fixation is staring at one instrument too long. Omission is skipping an important instrument entirely. And emphasis is putting too much weight on a single instrument, maybe one that's less reliable or less relevant at that moment.
And the second skill, interpretation.
Interpretation is understanding what each instrument is telling you, individually and collectively, and applying that knowledge to the aircraft's performance and the maneuver you're trying to fly.
It's more than just reading the dial.
Much more. It's about knowing why the instrument reads what it does, what its limitations are, and what that reading means for your flight path and energy state.
Can you give an example?
Sure. Imagine the attitude indicator shows a 10-degree nose-up pitch. In a small training aircraft like a Cessna 172 at full power, that might result in a climb rate of, say, 700 feet per minute at 75 knots.
Okay.
In a business jet, that same 10-degree nose-up pitch might give you a climb rate of 3,000 feet per minute at 250 knots. Same indication, vastly different performance.
Yeah.
That's interpretation based on aircraft knowledge.
So mastering attitude instrument flying really is about mastering that scan and interpretation.
Precisely. It's the combination of constantly gathering the right information through an effective scan and accurately understanding what that information means for controlling the aircraft. That's the foundation for safe IFR flight.
Excellent breakdown. Really clarifies those core concepts.
Glad to help. It's crucial stuff.
Thanks for listening.